I like today, I like fish. Sorry, I'm doing Peppa Pig. Okay, I do apologize. I like Peppa Pig. I was in England doing my PhD or my undergrad in England, and the British is so typical, The British, when they are impressed with something, they go, "Ooh!" Peppa Pig does that, and I will not stop laughing. And my daughter is like, "Daddy, what's wrong with you?" Okay. So, was that Marian that asked the question?
No, it's Jasmine.
Okay, sorry, Jasmine. Sorry, I do apologize. I was thinking like the whole class is just Mustafa and Mariam. Okay, it's not. I do apologize. Okay, so you were asking Eugene, what happened if the element A is here? Am I right?
Yeah, that's correct.
Okay, I got it. Okay, so if it's here, right? So we are. Wait, what am I? Okay, so we are going to find the shear. Right? So is equal to Bx over Iyy Qy. Okay, so we divide here. In fact, if I tell you the answer, you say, is that it? Okay. So
or
we
maybe the elements like a little bit further over, because I understand that the force is like coming down the web there, but I'm just wondering how the middle
I'm telling you this one.
flange
So
like
this one,
interact.
the Q is here.
Yeah.
So you want me to do on the left hand side of the centroid?
No, just beside the centroid.
Beside the centroid over here.
Yeah.
Okay. So just beside the centroid, you only take this area.
Would you not need to consider the area from the flange?
You have to consider this.
Okay. Cool. I just wanted to confirm that was the case.
Yeah, based on the rules. I'm not guessing. This one I'm sure, because I am consider the rules that I've written for you guys. Are we clear? Okay. So you divide this twice. So this is one area you consider. Wait.
Yeah, sir. With that area, don't you have to consider the 2Q?
Yes, you do.
Yeah, okay, makes sense.
Okay, give me time to think, you cheeky sort. Okay, I'm a slow computer. Okay. Okay. Now the reason is why. Anyone? Anyone? The reason is why. What?
Is it like wait, someone else going?
Yep.
No, is it like the WF and the W, like the flange and the web? You add those two together to get that sort of thing?
Yeah, pretty close. Okay, but that's different. But you have to consider that area of influence. Okay. Okay. Any other? This is a good one. Okay, and also based on the 4 rules or the more rules. Now I don't know. I make how many rules? It's like a Chinese guy receiving 15 commandment from God. He dropped 5 of the commandment because each commandment have to be put on a tablet, and a tablet only can have 5 commandments, so it's 15. So on the way down, he dropped 5 and he says 10. A Chinese guy like me, so careless, unbelievable. Okay. Anyone else? Any questions, please?
I just the last thing. So for a situation like this, essentially the rules, we use the rules and we follow the shear flow. So it would come from the side, like from the right, and from the middle.
Yep.
Okay.
But remember what I show you guys, right? From the middle, if it's thin wall, is very small. So I've seen example where they take it off. I don't want to take things off. Okay, I just leave it there. Okay. Anything else?
Also, Jeevan had a question in chat.
Oh, where? I can't wait. Roof. Thank you for telling me. Where are you? What thickness will you use for that type of question? Jivan, I will tell you when is a thick wall and when is a thin wall. Okay, I'll tell you. Now, some of you say, Eugene, this is BS, man. Okay, you tell us now. Now, my question for you is this. In the real world, what will you do? You were not told. Anyone? Let's say you are designing a structure now. By the way, 3A notes, okay, I will not what do you call, I will let you access 3A notes as long as you are a student at McMaster, or I don't know, are you allowed avenue to learn access after you graduate? Anyone knows? Let's say now you're graduate, can you still access avenue to learn? Anyone? No answer? No, we lose access. Okay, so I'll leave it on until your graduate. Okay, so you can access my avenue to learn anytime, because when you do 3E, 4MO6, any design work, you are bound to forget. Okay, so feel free to access them, and then also link you guys to the YouTube, right? Use it, man. Okay, I want you guys to be great structure analysis, not Mickey Mouse crabby ones. Okay, okay. What thickness will you? So what do you think? What thickness will you use? Test for both. Mohammed, you're right. Okay. So if you are not sure, okay, you can write this out. Okay, I'm going to test it based on thick wall analysis. So you work out thick wall. Then if you feel that, hey, I'm in a borderline, okay, in industry, no one would tell you. You test it in the thin wall analysis also, and you see your outcome. Okay, then you write down an assumption. Based on my test in thin wall analysis, this is a stress state. Based on thick wall, this is stress, the other stress state. And then you just write down to be safe. Okay, you want to be safe. Okay, in your opinion that you want it to be safe, I'm going to consider thin wall because the stresses are much higher. Okay, so not everyone are taught thin wall analysis. Okay, so there are people that only know how to use thick wall analysis. So what then? This is the difference. Okay. No, you go for the maximum in terms of stresses. You don't go for minimum. Okay. Now the thing is this: if let's say you don't know thin wall, you only know thick wall, right? So you are not sure. You just put a factor of safety of 2, for example. Okay. Put a safety of 2. Put a safety factor of 3. Or really not sure, or don't know how to do shear stress analysis. Your factor of safety, okay, your factor of safety, if you are not sure, you put 10. You don't know, okay, you guys know, okay. So that's why factor of safety to me is, the acronym is not factor of safety. It's full of shit, right? You don't know at all. You just, okay, 10, okay. It's fine when raw materials are cheap. It's fine when your structure don't fly. It's not okay when your structures are moving. So which type of engineers deal with moving structure?
Mechanical.
Thank you. Okay, that's the difference between civil engineers and mechanical engineers. We have to be very precise. Okay, that's the important part. You can, I mean, I've taught profs that in structure analysis on this. In civil, they don't really care. They just not sure, put 10. No, we can't do that. Okay. Professor, here we design for failure. What other concept will we have to design for in real life? So failure, you design things for failure. Okay. That's where the economics come in. If you want people to buy your things more often, okay, you design for earlier failure. If you want to design them to last forever, okay, you make them thicker. There you go. Okay, it's all tied back to economics. Okay, unfortunately, that is why the car company Rolls-Royce collapsed. People, they're filthy rich, only buy one of theirs, and they pass down 4 generations. Japanese are smart. They say inai ne, which means no. I want my customer to buy the car, a new car, every 8 years. I'll design the car. After 8 years, you don't drive the same old car. I mean, I am cheap and thrifty. I do still drive the Mazda that's 8 years, but not a lot of people are like me. Okay, so they were designed to a lifespan of 8 to 10 years. But You don't design a car that fail within 3 years, okay? That design is called not well designed. Because every time people go back so often, in the end, they will not buy from you anymore, okay? At the center for this situation, is it box beam analysis? No, white flange. Yes, white flange.
Sorry, Professor.
Wait.
You might have mentioned this.
Wait, this is box beam because you only consider, or if you want, it can be white flange if you consider the whole area. I would, if you do what I teach, you consider the whole area. You don't divide the area into two first. Okay, you are right, Mira. It's 2Q. Mira, you are right. If I don't follow what I've been teaching you guys, or follow some of the textbook, okay, is if they already know that this is this area is the one carrying the Q, you can just use Q. But I don't want to confuse you guys. I've been always teaching you, like, consider the arrow based on the analysis direction. Right? So yes, you consider it's 2Q, Mira. Anyone else?
What's the, like, if we took like the element A that you drew over there, what's the T that we use?
So so if it's this area that we are looking for, right? This is the thickness.
No, sorry, I meant the other point.
This is still the thickness.
So we don't include the thickness of that tiny small area?
No, we don't.
Okay.
And I will not ask question like this, okay? Hello?
Okay,
Miriam.
good.
Okay, if I'm going to pick a point, okay, I because now it's testing of your understanding, not of your philosophy on what you believe, okay? So I will call it here, or put one here, or put one here, okay? Any idea what does a PhD stand for? Anyone? I have a PhD, but what does it stand for? Anyone? Anyone? You will have a bachelor when you finish, right? I have a PhD, so anyone know what it stands for? Right, permanent head damage. Emily, you are absolutely right. Okay, so I don't want to damage your brains yet until you do your PhDs. Okay. Any other questions? Any more? If I don't hear anything, I will start on Mo circle. Then all of a sudden, a lot of questions come up. Okay, okay. What I'm going to do now is knowledge for you guys that you apply. Okay, in the later course. There's I won't test this, by the way. Okay, so now, so in your homework, right? In your homework, you are always asked to find the principal stress and maximum shearing stress, right? So now this is a tip. So you get any material property handbook, you see this. Okay, you see density, you see tension, you see, so ultimate strength, yield strength. Okay, you see E value. These are straightforward. These are very easy to understand. Okay, now let's say now, okay, so from today's example, so we look at today's example. So today's example, the element, where's today, or this morning? Okay, so this morning example, okay, you have stress state like this. Okay. You have stress state like this. Okay, so this is so you calculated already, and this is your stress state. Okay, right now over here we have a normal stress, and then we have a shearing stress. Question for you guys: what value will you use? Anyone? What value will you use? Anyone want to make a guess? So we have tension ultimate, tension in U,